Yep, it's recording. Now, first hour. Messed up the recording, so we're going to start from scratch. That's so my first hour children know when they look on there and wonder why they get the same thing again. But here we go. Hyperbolas. The hyperbola is a conic sections. And remember when I first started talking about this, I said conic sections because they were really two cones. All right? Well, hyperbolas are that situation. Here you go. If you have the two cones, and they're connected right there, vertex to the cones, all right? And you got your cones. And there's a line that runs right through the middle of them, line of symmetry. Fair enough? Right through here goes through the vertex. Well, what happens with a hyperbola is your plane that cuts it is parallel to this axis that runs through the center of the cones. You got this axis going through the center cones, and then you cut it with a plane that's parallel to that axis. And what that does is it gives you these little U shapes coming out. And they're really more like a V shape than a U shape, but that's what happens. You'll think it's going to be like a U going down where it cuts the cone, and a U going what? Up where it cuts the cone. All right? And of course, if you put the cones on their side, you get a U going left and a U going right. But that's how you get the hyperbolas, is you cut the cones parallel to this axis through the center of the cones. All right? And that's the hyperbola. And it's the only one that uses both cones. So when we say conic sections, we're saving that just for the hyperbola. Now, we're going to talk about how to graph the hyperbola today, what the formula looks like, and we're going to compare it with the ellipse formula a little bit, but here we go. When you look at the hyperbola formula, the easy way to tell it's not an ellipse and it's a hyperbola, there's a minus sign. Notice how I kept talking about ellipses and circles and I kept stressing the plus sign? Well, now there's a minus sign there. That makes the hyperbola. But there is a problem with having a minus sign. When you have an addition sign, you've got the commutative property that you can put, you can do A plus B or B plus A, right? Does that work for subtraction? No. So really there are two formulas. There's one where it's X minus Y, and there's also the formula where it's Y minus X. Now, what causes students trouble with this is they don't realize all the information over here is about your Y, and all the information in the second part is about your X. Because you're so used to the X being first that you think all this information is X information. It's not. In this case, all this information here is what? Y, because it's close to the Y. Now, I'm going to tell you the big difference between the two. Oh, and notice I didn't put bigger or little under here, because it doesn't matter. You're going to have a number squared here and a number squared here, and it doesn't matter which one's larger or smaller, so we don't have to worry about that. Here's the deal. If you have hyperbolas that are X squared minus Y squared, they're going to open to the left and to the right, because this X is going to have to be larger. All right? So they've got to have X. They've got to be X directions. X is first, and what does X do? Left and right. Now, and they really should line up better than I did. But here's the vertexes, and then the foci will be out here like so. But that's what happens when you have X squared minus Y squared. They're going to be left and right. Now, when you have Y squared minus X squared, you probably have already realized they're going to do what? Up and down. And there's your two vertexes, and here is your foci. So that's generally how they'll look, based on which one's first. So far, so good. somebody says, well, do the numbers here and here, yeah, they're going to affect the shape, but they don't determine the direction. You can have the larger number here or the larger number here, but this one's still going to open what? Left and right. Hyperbolas. We're going to work one, and as we work it, we're going to write out our steps and work an actual problem. So we're going to do this. X minus 2 squared over 9 minus y plus 1 squared over 16 equals 1. Okay. First thing you want to do is identify whether it's a left-right or an up-down. This one is a left-right because it's what? X squared minus y squared. First thing, find the center. Okay, step 1. After you determine which way it opens, find the center. What's the center for this one? 2, comma, negative 1. All right, find the center. Now, after you find the center, find the 4 key points, just like if you were working an ellipse. Now, you want to think of this as being 3 squared, and this as being what? 4 squared. So you'll count 3 in the x directions. Count over 3. 5, negative 1. Count backwards 3. Negative 1, negative 1. How much are you going to count in the y directions? Come on, say something. How much are you going to count in the y directions? 4. Notice, it's just like when you were doing the ellipse the other day. Count 4. So you get 2 comma 3 and 2 comma negative 5. Now, up to this point, we have done exactly like what we did with the ellipse. Please don't draw an ellipse. Sorry. Yeah, because you're so used to drawing an ellipse, what's the first thing you do? You try to draw an ellipse. Don't do that. Okay? Don't draw the ellipse. Or, if you just drew an ellipse and you want a really pretty ellipse, put a plus sign in between them, then you'd have the ellipse. But, hyperbola. All right, here's what you're going to do. We're going to make a rectangle to help us draw the hyperbola. And the rectangle we're going to make, the sides are marked by those 4 key points. The sides of the rectangle are marked by those 4 key points. In other words, they tell you what the length and the width of the rectangle is. They help you with your rectangle. And that rectangle is important. And does everybody agree that if these numbers change, the length and the width of that rectangle are going to change? Okay? That's important. It's important. All right. Now, so you make your rectangle. Don't make triangles. Don't make diamond shapes. Don't make any shapes except a what? Rectangle. I see all kinds of weird stuff when people turn this in. All right. From that, you are going to draw a really special line. We'll tell you the name of them in just a second. But for right now, let's get them drawn right. It's going to come down. It's going to go through the corner, through the middle, and out the other corner. All right? It would do that for a rectangle. All right? So, you're going to come down. You're going through a corner, through the center. And if you had graph paper and you're doing it absolutely perfect, it would go right out the other corner. There's one of them there, and there's one of them here. Right through the center. Those 2 lines are going to help us draw the hyperbola. Okay? Those 2 lines are going to help us draw the hyperbola. And those 2 lines have a special name. I never can spell it, so I'm not going to get it wrong. Asymptotes. They're called asymptotes. asymptotes, you're going to talk about them in calculus. You don't talk about them in statistics, but they're a part of statistics. But what asymptotes do is they give you an idea of what's happening at really big numbers out that way, or really small numbers back this way. They keep you, they make the math easier. And I will show you why in a few minutes. But what they do is they tell you basically what the shape of this is going to be as it goes out. They tell you whether it's going to be kind of narrow or kind of wide. Because when you draw the hyperbola, which you are now ready to draw, the hyperbola that you're going to draw, make sure you realize it does not go inside of the rectangle. That point is close, it goes to that point. But what it does is it curves off and it gets forever closer to that line. And it comes down and it gets forever closer to the asymptote. That's where the asymptotes help you. They show you where it's going. Please do not go inside of the rectangle. It's the point right there on the box, right there on the edge of the rectangle. And it doesn't go straight up, straight out. It is a curve, and it gets closer and closer. Okay? Please don't go up here, get real close, and then bring it over like that. That doesn't look right. It does what? It comes up and it gets what? Closer and closer to the asymptote. The asymptote tells you where it's going. And you've actually drawn the hyperbola now. You got the hyperbola. Now we're going to tell you a little bit more about our hyperbolas, but that gets you to the hyperbola. And do you realize if I were to change this number, it would have made this side closer, which would have changed the angle of the asymptote? See, as that rectangle gets narrower or longer, it changes the angle of the asymptotes, changes the angle of where the hyperbola goes. And now you also may have realized why I said it looks more like a V shape, because it really gets almost to be like a straight line out here, and what? A straight line down here. All right. Next step. Let's make sure we've done this in order. We found our center. We found our 4 key points. We drew our rectangle. We drew our asymptotes. And then we actually made the graph of the hyperbola. We're going to find the foci next. Foci time. Here we go. The formula for the foci, for a hyperbola. Center to foci is equal to the square root of the number under the x squared, or this part, number under the x squared, plus number under the y squared. Notice it doesn't matter which one's larger or smaller because we're adding. Big plus sign in here. It's not the same as the ellipse formula. It has a plus sign between them. It has a plus sign there. So, center to foci is equal. I didn't want to work it there. I want to work it over here on the problem. I'm going to leave this for all my little formulas. All right, center to foci. C2F equals square root 3 squared plus 4 squared. You work that out and you find out it's 5. Please do not take the square roots of them separately. You must square them and then add them together. Then take the square root. You count 2 plus 5 is going to put you at 7. That's a focus. And then 2 minus 5 is going to put you at negative 3. And that's a focus. And I didn't even mention this in first hour today, but the major axis, and we're not going to talk about major and minor axis in this case too much, but the major axis is the one that goes through the vertices and the foci. That's the major axis. On the ellipses, it was which one was what? Longer. Not here. The major axis here is y equals what? -1. Major axis is y equals -1. I'm going to go ahead and put that. Major axis y equals -1. Just a little note. You're going to hear about that. I don't really worry about it. But there it is. And there's your foci.
How'd you get the foci?
All right. I did 3 squared plus 4 squared, 9 plus 16, then I got 5, took the square root. Is that all right? Then remember, you always count from the center. And it has to go into the opening. See how I gave you a little, so it's going to be 2 plus 5, 7, 2 minus 5, -3. And is that enough information? Does that help? Okay. And you're doing your count. All right, now let's get to the last little thing I have to teach you about these. This is the part that I really care about. Well, I care about the whole thing, I guess. I'm getting old and grumpy. All right, we are going to write equations for the asymptotes. We have to write equations for the asymptotes. And when we write equations for the asymptotes, we are going to make this pretty straightforward because we're going to use the same formula. We're all going to use this formula. Y minus y sub 1 equals mx minus x sub 1. And folks, we're always going to get, this is the point slope formula. We're going to use the center as our point. Put a big star and put, we are using the center as our point. And we can do fill in the blanks mathematics. But what are we always going to use as our point? The what? Center. If you don't use the center, you can still get the right equations, but it's harder. So we're going to do y minus -1. Everybody says that's a +1, Mr. Evans. Yeah, I know it is. And x minus 2. Because we use the center. Now, we really have 2 lines. So I'm going to write that down twice. The second time I write it down, I'm going to simplify it. Okay? I'm going to simplify it there. These children don't need that. All right. Now, let's talk about the slope. When we do slope, Mr. Evans wants you to think of slope as the change in y over the change in x. And we always want the change in x being counted to the right. We never want to do change in x going that way. We don't want to go to the left because it messes up the formula. And then if we have a positive change in y when it's going up, and we have a negative change in y when it's going down. But in order to trust this, our change in x always has to be positive going to the what? Right. So we're going to always measure slope from what? Left to right. Okay, let me show you how to get the numbers really easy. See the center? How far did you count over to right here? How far did you count from here to here? 3. Now, how far did you count up from here to that corner? How much you count up here? 4. So what did you count up there? 4. And then one of them you counted up 4, the other one you counted what? Down 4. So always think of how far I went from left to right, and then do what? Up and down. Never count your change of x going back to the left. Somebody says, Mr. Evans, there's an easier way. The number under the y told you the change in y, and the number under the x told you the what? Change in x. You're right. You're absolutely right. It did. All right? Somebody also noticed that you might see that you get y plus 1 in parentheses and x minus 2. Look what you got over here. Okay? Yeah. Because this formula is based on the center, and we're using that formula based on the what? center. The only reason that works out that pretty is because we're based on both on the what? Center. Question. Take a look at it.
Will it be every time like that? It'll always work like that?
That's going to work like that all the time, yeah. Because you're going to sit there and count, and you always got from the center to here, and then from here up, or from here what? Down. The person it doesn't work for is the person that goes, oh, I'm going to count backwards. Okay? They're going to count backwards, and it can be done, but then you're changing X as a negative, and you got to deal with all that. And we don't want that. We're going to make our change in X a positive. Don't make fun of anyone, Mr. Evans. You're on camera. I got this from one of my kids years ago. I found it when I was cleaning out my desk this summer. Yeah. I mean, see, that's back when education was strong. We didn't try to make sure everybody understood. We just said right up front, what? Crush the weak. So the kid that gave this to me, he's now a PhD in some kind of chemistry. I don't know. And he gave this to me when he graduated from high school, because I always used to use that expression. And then somebody said I was going to hurt some child's feelings, so I quit using the expression. And now I'm putting it right back up there. When you go to college, I want you to make the students from the other schools look bad. All right, eccentricity. Eccentricity is the same formula as it was for the ellipse. So, center to vertex was 5, and center to focus was 5, center to vertex was 3. All right? How far is it from here to here? How far is it from there? And what you'll find out is the eccentricity for this is always a number bigger than 1. Eccentricity for these should always be larger than 1. And eccentricity for your ellipses was always what? Less. So if you go back, let's write that formula down here. Eccentricity, not electricity. Eccentricity is equal to center to foci over center to vertex. And I have to go look that formula up every once in a while. Now, what I'm going to do is everybody happy? I'm going to let you look at that for a moment or two and make sure you're really happy with it. I promise not to laugh at you because I'm on camera. I don't want to get in trouble. Anyone? Follow the same procedure over and over. Learn the procedure. That's the key. All right. Now, what we're going to do, I'm prepared. All right. There we go. Except now it doesn't look as pretty. And don't try to make it perfect, Evans. Just get over here and hit the assignment button. What you're going to find out is this assignment is not published yet, so you can't read it. And the only reason it's not published yet is because I had to put the videos with it, show people how to do it that are at home. But if you click on that button, you will see that I did get you 4 problems to work. Now, if you work, you can put this in your pictures of your 10 problems, right? Okay? And some of you may be a little bit behind and go, Mr. Evans, I'm not going to get all of that done before Friday night right there. I don't expect you to. I expect you to give me an hour tomorrow and an hour Friday. And you'll probably at least get 1 or 2 of these done. All right? Because you still got some other assignments from the past. Fair enough? Give me the 2 hours, and then next week you can work on this a little bit more. All right? Now, what I want to do is I want to lecture on the left-right type in this class, And next hour, I'm going to do the lecture on the ones that go up and down, which all of this is the same. It's just so you can see one that goes up and down. And when I post the videos this afternoon, there'll be a video left, right, video up and down, and every class can see it because we'll have each one. All right? I'm going to let you work on these a little bit, and we'll get you ready. Is there any questions as far as how assignments are working? Y'all do know